Alright, so today we will look at data wrangling with R. I have uploaded, or at least linked to this PDF on CCLE. Okay, this was originally put together by this guy Garrett Gromland. He works for RStudio, and he did, in my opinion, a great job of covering two packages that are important, tidyr and dplyr. And so we will cover tidyr today, and on Friday we will cover dplyr. And so if you want to follow along, you can download this, or you can just watch the screen here. Okay, so I am not Garrett. These are his slides, though. And this is what we will cover. This is a link to a cheat sheet. RStudio has produced some cheat sheets, and they are very good. We have cheat sheets for R Markdown, cheat sheets for the RStudio IDE itself, along with Shiny and some visualization cheat sheets. This one in particular is the data wrangling cheat sheet. It will summarize pretty much everything we're covering today regarding making tidy data and then summarizing data with dplyr. Okay, so today we'll cover just the tidy part. On Friday we'll cover dplyr. Very good packages. One thing we'll see is tibbles. Tibbles are a data frame with a few extra nice little features that play nicely with the console window. So you might have seen, when you've typed in the name of a data frame, and R just spits out the entire data frame and it fills up your entire console window, right? And so what a tibble does is it only displays what your console can show. And if it doesn't fit in the console window, it will put in ... to indicate that there are more lines, and it will also put in the column names and say, like, these are the column names that did not show. And it will just put some nice little things as far as displaying information in RStudio. So that's a tibble. But the tibble, if you look up the class on a tibble, it will be a tibble and a data frame. And so any function that uses a data frame can use a tibble. It's just the tibble just has a few nice things to it so that when it prints in your screen, it's not so crazy. Okay, and of course I think we're familiar with the view function, where if you have a data set in RStudio, you can click the name of the data set in the environment and it will appear as almost like a spreadsheet, or you can use capital V view to make the data appear in RStudio. And we're already familiar with the pipe operator when we looked at rvest, so we don't have to cover this again. So we can just kind of shortcut things using the pipes to say, just take the data, pipe it into another function. Okay, so all of this to say we're going to focus on data wrangling. And data wrangling, Garrett says maybe it consists of 50 to 80% of your time. I'm not sure about that, but it does take a significant portion in just kind of cleaning up your data. So if you pull data from pretty much anywhere other than R, you're going to have to do some cleaning up. Some of it you're going to have to do some text cleanup, but other times the data itself is just formatted a little bit poorly. So today we're covering tidyr. dplyr will cover on Friday. We'll cover dplyr, and on next Monday we'll look at regular expressions and handling text. And so this will handle a lot of your data cleanup missions if you've gained a mastery over those things. Regular expressions will take a little while to, I would say, become a master of, but if you're familiar with regular expressions, you can do a lot of powerful things relatively quickly and easily. They're like magic. Okay, and so we have two goals. Make data suitable to use with a particular piece of software. In our case, the software is R. And we also want to reveal information when we're looking at data. So the reveal information falls under the dplyr part. Making the data suitable for usage falls under the tidyr. So we say data sets come in many formats, but R prefers just one. So before we get started, we are going to look at a few sets of data, and they are available in this package EDAWR. And in order to get those on your laptop, if you want to follow along, you're going to have to run these two lines. Install.packages devtools, if you don't have that already. And then within devtools, you want to use the function install_GitHub and name the package RStudio EDAWR. You can't just do install.packages EDAWR because it's not in the CRAN repository. So CRAN has a bunch of packages, so whenever you say like install.packages ggplot2, that's already up there. But EDAWR for exploratory data analysis with R, I think is what it stands for. That's just in the RStudio's GitHub, and so you have to use install_GitHub to use it. DevTools : means use the function inside package DevTools. Last class students asked about the double colon, which is a good question. Why do we use the double colon, or what is it for? It's a way to specifically identify a function that exists in a package. So for example, in dplyr, there's a function called filter that you'll use a lot. But there's also a function called filter that exists in, I think, base stats. And so if you want to be able to distinguish between the filter and the other one, R has these scoping rules which says, start at this current environment, then go up to the parent environment and keep looking that way. And the last library you loaded will be the parent, right? And so there's kind of this chain depending on the order in which you loaded your libraries. If you want to, say, find this particular function, not necessarily according to our scoping rules, then you would say, package name, : function name. And so you could say, find dplyr, : filter. And that would be the filter function inside dplyr. Or you can say base stats, : filter. And that will be the filter function in base stats. Okay, did we all do this just in case we want to follow along? Okay, and then do library EDAWR, and that will load up the data. Okay, and you can take a look. You can just type in storms, and it will print out the storms. You can type in capital VIEW storms, and that will throw storms here. And the package also has some help information on the storms, and these are wind speed data for 6 hurricanes collected from the National Hurricane Center's archive of tropical cyclone reports. And we just got the first for 6. So that's, and we're going to look at storms, we're going to look at cases, which is cases of tuberculosis, I believe, cases of TB cases in USA, Germany, and France. And then we'll also look at pollution. And we can ask about that. And it just gives a little information. Pollution data from World Health Organization 2014. So that's what we're dealing with. And the data looks something like this. So we've got storms, which looks like this, cases, which look like this, and pollution looks like this. So if we take a look at the storms data, we see that each column is a variable. Okay, we've got the storm name stored in a column. We have the wind speed stored in a column. We have the pressure stored in a column, and the date when the storm happened is also stored in another column. So here we go. Each column has, or each variable has its own column here. If we look at the cases table, what does this number represent? 7,000. That means France in the year 2011 had 7,000 cases of TB. This 6900 says in France in the year 2012 had 6,900 cases of TB, and so on and so forth. So what are the variables that exist in this data frame? Yeah, there's really just two variables. We have country and we have year. Those are the two variables, and the data itself, the values that we're interested in, is stored out here, and this would be the count. Okay, so we really only have three values: country, year, and count. Okay. Over here we have pollution. We have city, we have particle size, and we have amount. But if we think about it, there are three variables, and I would say those three variables are the city, the number of large particles, and the number of small particles. So if we look at how the data are stored, the number of large particles are in these three rows, and the number of small particles are in these three rows. Okay. And so this first form, the storms, this is what we would call tidy data. And R works very nicely with tidy data because you can reference each column or each variable. If you wanted to get the storm, you would just do storms, $storm, or $wind, $pressure, $date, and this gives each of the variables that you're looking for. In this case, you can get the country by doing $country, but if you want the years, you'd have to do the names, which would be each column, country 2011, 2012, 2013, so it would be the names, the column names, minus the first one. And then the actual values themselves, you'd have to do some kind of crazy thing, unlist all of this stuff here. So it's just not pleasant to try to work with it that way. And then as far as this table goes, if you want the city name, you can just take the, New York, London, and Beijing. Here we took the odd rows. If we want the large particles, we would take the odd rows in the amount column. And if we want the small particles, we would take the even rows in the amount column. And we can see this would get very ugly to deal with for any larger data set, right? So the idea is we want to turn data that's formatted like this into data that's formatted like this, or data that's formatted like this into nice tidy data. So this would be tidy data. Okay, storms are tidy data, and a nice thing that you can do with tidy data is you can create new columns by taking advantage of the vector form of arithmetic that R does. So if you want to create a new column called ratio, all you have to do is do storms $pressure divided by storms $wind, and you would get a new column of pressure data. Ratio. Okay, and you can store this as a new column there. So because it matches these two values, calculates something out. And so with tidy data, each variable is its own column, each observation has its own row, and each type of observation is stored in a single table. So here we go. So that's tidy data. That's what we want to be dealing with. What do we do if your data is not tidy? How can we do this? So we can use the package tidyr, and there are two main functions that tidyr can do: gather and spread. So you can install that package's tidyr, load up the library tidyr, and the two functions we'll use are gather and spread, and you can always look up the help for gather and spread. So just give everybody a chance to get tidyr loaded into their machines, and then we'll take a look here. All right, we all good? All right, so if we were going to turn this table into something in the form of tidy data, we would end up having three columns, right? The three variables that we have are the country, the year, and the number of cases, the count of cases. So if we turn this data into tidy data, how many rows would we end up having? 9 rows, right? And this is what it would look like. We would have country, year, and number of cases. And France 2011 7,000 would get 1 row. Germany 5,800 in 2011 would get another row. America in 2011 with 15,000 would get another row, and so on and so forth. France, Germany, America, France, Germany, America. We would have a total of 9 rows. And so this is how we want our data to appear. And so the function that we use to get data going from here to here is the gather function. Okay, and once we use the gather function, each variable would be in its own column. And that's exactly what we want. Okay? And so when we are gathering the data, we have to give it a key and we have to give it a value. Okay? All key does is it takes the column titles, 2011, 2012, 2013, and it throws them into this column. Okay? So whatever the column title is, those become the new values in this key column. Okay? And so, you know, here the columns are formatted nicely, they make sense, but you can, if the column name was something crazy, it would still just, the crazy thing would appear in this key column, okay? And then you give it the name. What do you want to call the key column? We're going to call the key column year. Okay? And then as far as the values that go over here, the values that we're gathering, we're going to say gather the columns, the values in columns 2 through 3, or 2 through 4, 2, 3, and 4. So the way it goes is we're going to say take the data in cases. We're going to create a new column. That column is called year. This is our key column. And then in that year column, you know, we're basically going to take the titles of the columns in 2 through 4, and then the other values in 2 through 4 that aren't the column things will end up in this column that we're going to call N. Okay, so this is the key and this is the value. So we're going to say this is the name of our key column, this is the name of the value column. The names here are just arbitrary. They don't actually have any meaning to them. It always makes sense to use names that make sense, but if you wanted to call this happy-go-lucky year, that will appear as the name of the column, okay? And so, so let's try this out, okay? So what I want to do is we're going to look at the table cases, all right? And I can run gather on cases. We're going to create a column called year. We're going to create a column called N, and we're going to collapse columns 2 through 4, 2011, 2012, 2013, into our table. And ta-da, it did it, okay? So this is exactly what we want. Now, I want to point out that, again, there's no significance to the name year. I could call this when did it happen? And that just becomes the name of the column. So there's nothing particular. We can change N to how many people had TB. And these are legitimate column names, although I would not recommend using them just because in general when you have variable or column names, short and sweet is better. But this is fine. Country, when did it happen? How many people had tuberculosis? Okay. But it probably makes sense to just stick with N and stick with year, because I think we know what those mean. As far as the column names though, okay, what this does is what gather does is it takes the column name and it throws that into here. So I'm going to modify in cases. I'm going to take cases, what are the column names of cases? Names and cases, these are the column names. I'm going to change the second name, 2011, and I'm going to call this the year 2011, okay? And so if let me just pull up view cases again. So this is what the cases table looks like now. It's called country, the year 2011, 2012, and 2013. So if we say print cases, this is what will happen, and I'm going to just gather cases in the same way. We're going to gather cases. The keys will go in year, meaning the column titles will populate the column year, and then N and 2 through 4. And so all this does, okay, there's nothing special about these column names. It just says, oh, what was this column called? It was called the year 2011. That is going to fill out these rows here. So it just takes whatever this thing is, and that becomes the value. Gather and R is not intrinsically knowledgeable of what your data represents. All it's doing is it's taking the column names and turning them into values that go into the key column. So if you wanted to have something strange like the year 2011, that could go there, okay? If you wanted to call it, instead of the year 2011, you wanted to call it, I don't know, just blah, 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 okay? That's fine, okay? This is the thing, and when you gather it, that crazy thing goes in. So it's just the column name. All gather does is it takes the column names and it just throws it in as key values under here. And it takes everything else that's not a column name and it basically stacks them on top of each other into the value column. Right. Does that make sense, what gather is doing? Any questions here? All right, so I'm going to just call it 2011 and gather it. And so this is what we want to do. Okay, so that is gather. Okay, we're going to take a look at the other function, spread. And so in this case, we're going to take data that looks like this, and we want to turn it into a table with city, large, and small. So how many rows will this table end up having? How many rows? 3 rows, right? And we would have 1 row for each city. Okay. So here we got this information. We're going to create 3 columns: city, large for number of large particles, small for the number of small particles in the air. And we're going to say New York had 23 large particles and 14 small particles. London had 22 large particles and 16 small particles. Beijing had 121 large particles and 56 small particles. And so the function we're using here, okay, and again, just to emphasize that this ends up being tidy data. Each column represents a variable. The function we're using here is spread. We're spreading out the data in one column into multiple columns. So the other one was called gather because we're taking data that's in multiple columns and gathering them into one column. And this one's called spread because we're taking data that's in one column and we're spreading them out to multiple columns. And so the way we're going to spread is we're going to give it the column that has a key. All right. And so here we are going to say, oh, we've got in this column that says size, we have large and we have small. We want to use these as column names for the values that we have in here. So we want to create a column that says large and a column that has small. And so we give it the key and we give it the column that stores the values. And in this case, we would say the values that we want to spread out are in this column amount. And so that's what's going on there. Okay, and so in this case, we're going to take spread, we'll take the table pollution, and then it's going to take the column size, use that as a key. This column size, the values in there will form new column names. And it's going to take the values in the amount column and turn them into the values in our new columns. Okay? And so here we don't have quotes, these are actual column names. And so here the names and the spellings, they matter here. Okay. So this is what we've got. So let's do that. So we can do spread. So let me pull up our table, pollution. And let's do view pollution. Okay, so this is what it looks like. New York, London, Beijing. And what we want to do is we want to spread out the values in the amount column. So we're going to say spread, use the table pollution. The keys are in the column size, and the column that we want to spread out, the values there are in the column amount. Okay, and so that's what it does, is it takes the values here and it says, I see Beijing 121 and 56 and so on and so forth. Okay, here the values, the way things are written out in this column for the key matters very much. Okay, what the spread thing does is it says, oh, you've given me the size column, I'm going to look in the size column and find the unique values. Here I only found two unique values, large and small, and so I'm going to form two columns here. Okay, and it's going to say, okay, I found the value large, and so what I'm going to put into the large column will be 23, 22, and so on and so forth. What we're going to try to do, well, let me just show you what would happen. Let's say in pollution, $size, I'm going to just change one of these, the first one, from lowercase large to capital large. Okay? All right. I'll just spell large this way. All right, and so let me just do view pollution. Okay, and so over here I've got large spelled with a capital L, capital letters. So what will happen if I do spread, if I run the same command here? Spread pollution size amount. What's it going to do? It's going to have another column here. Okay, it's going to have a column for lowercase large, and it's going to have a column for uppercase large, because it doesn't recognize, like in our brains we can say, oh, those are talking about the same thing, but here it's very strict. It's going to say, oh, okay, I'm trying to match up, you know, does Beijing have lowercase large particles? Yes, it has 121 of them. Does London have lowercase large particles? Yes, I found 22. Does New York have lowercase large? No, I couldn't find it, so it's going to put in a missing value. It's going to see in size we've got something called capital large, and it goes through and it says I couldn't find anything for Beijing or London, so it puts in missing values, and it says but New York has 23 of these things. Okay, small because they all match up, it's going to work out there. Okay, so that is so when it's looking down this column that we give it as keys, it's going to try to, it needs exact matches. So let me just change that back to large. So if I change it back to large and I spread it out, it works fine. What would happen if I mix up the order? If I did amount and then size? What would our resulting table look like? Okay, I would have 6 different columns, and what would be the thing that goes in each column? Large or small, right? So here it thinks, okay, Beijing, it's trying to match it up to 14. It says there's nothing, you know, it just says New York under column 14, there's a small value, okay? And so this all gets messed up, right? This is clearly not the way we intend to have it, okay? And And the way, again, when it's trying to kind of combine rows, the rows need to be spelled the same way here. So if I change, let's say, pollution city, let me just make sure, I think this one will say New York, right? Okay, so I'm going to just change this. If I call this NYC, whoops. Okay, so over here, again, spread tries to spread out this column into multiple columns, and collapse the number of rows. And so if I did spread on this, how many rows am I going to end up having? How many columns will I end up having? I'll have 3 columns and 4 rows, right? So I've got, it was able to combine the rows for Beijing and London and spread those columns out, but New York and NYC, it couldn't combine those. And so New York has 14 small particles and NYC has 23 large particles, and it wasn't unable to match the other ones. So again, so spread tries to reduce the number of rows by spreading out the data in one thing into multiple columns. So that's spread. Okay. So going from a table like this to this is spread. And actually, if we wanted to go back the other way, this would be gather. Okay, so spread and gather are kind of like inverse functions. Spread takes one column of data, spreads it out over multiple columns. Gather takes multiple columns of data and gathers them into one. And so let me just kind of show you. So let me just store the result of spread over here, and I'm going to just call this POL. Okay. And so if I do view POL, then I've got this, and I can gather these two things, right? So I can gather POL, and I want to gather and create a new column where I'm going to store the key values, right? So what should I call this thing? Maybe I'll call this particle size. And then the other thing I can say number of particles, or I'll just call it number. And what we want to do is we want to gather columns 2 to 3. Okay? And indeed, that's what it does. It gathers and it populates the values in particle size by using the column names, large and small. Okay, so that's spread and that's gather. And then we have so those are the 2 primary functions in tidyr, and you can manipulate data using gather and spread. There's also unite and separate. And so if we look at the storms data table, okay, we could also argue that the date column can be broken out into 3 columns. We could break it out into year, month, and day. And so this would use the function separate. Takes one column and treating it as a text string, it's going to break it out into multiple columns. So in this case, we can say take the date column and you're going to create 3 new columns. The way you're going to separate them is using the dash. Okay, so when you see a dash, separate that into new columns. And then the 3 columns I want you to create, we're going to call year, month, and day. Again, these are just arbitrary labels. It makes sense to call them year, month, day, but if you want to call them YMD, that's also fine. Okay? And that is separate. So this is basically just doing some text handling on the storms column date. So I can say view storms, and let's also just throw storms here. And we can say separate from storms. We want to separate the column date. The new columns we're going to call Y, M, and D. And the way we're going to separate them is by using the dash. Oops. No, helps if I spell the data table correctly, storms. And so there we go. It has created 3 columns. It has turned the column date into 3 columns, year, month, and day, or YM and D. So that is separate. And the flip side of separate is unite. Okay, and so all unite does is, so if I store this as storms2, it just says take these columns, year, month, and day, and glue them together. So it says unite storms2, take the columns YMD, throw them together in the date column, and when you glue them back together, don't just glue them back together, but put in a dash to keep them separated. But I'm going to just change it just a tiny bit. So over here, we're going to say unite storms2. We're going to create a new column called date. And we're going to take columns Y, M, and D. And then the separator, we can give it just the space, okay? Or we can give it, you know, equal signs, okay? So you can, it's just basically gluing the things together. Or you can give it nothing and it just glues them together this way. So all we're doing is we're just taking different columns, and effectively we're running the paste command, okay? Pasting these column values together. And we're going to say, take whatever you've pasted together and make a new column. And that's what unite does. So, you know, maybe we're familiar with this. Did you guys ever rip CDs, like to add to iTunes or something back in the day? Okay, and then, so oftentimes, you know, to create your file name, you would have these options, right? You could say, like, I want the track name and then the artist name and then the album, or I want track number, then track name, and then artist or something, and maybe you would not include the album, and you can do this, and that's effectively what we're doing. We're just taking these different pieces of information and we're trying to combine them into one text string that we're going to store in a new column, and that's what unite does. And then separate just tries to do the opposite. You know, if you have this file name for, like, if somebody gave you their MP3 files and you wanted to separate those out and get the track number and the whatever artist and the things like that, you might be able to use separate on that. And so between gather and spread, unite and separate, you can do a lot to clean up your data and get the columns and the fields that you want, which I think is very useful. Okay, so tidyr, you know, does all of this stuff, and if you take a look at your data wrangling cheat sheet, there is, and all of this is covered in here. Where's, so you've got gather and you have spread. Whoops, gather and spread, it kind of shows you how these things go, and then separate and unite. And so these are, in my opinion, very handy. Okay, are there any questions? We're all good? Okay, looks like we're done a little bit early today, so we'll end here. On Friday, we'll cover dplyr and look at summarizing and uniting data that way. Okay.